For our previous lesson, which is lesson number 5, we have discussed there the matrices and the determinants. So we have there the solution of a set of linear equations. So we get the unknowns there, the three unknowns for the three linear equations by getting its determinant, and then second we express the equation to its matrix form, which is ax is equal to b, and then for number 3 we get the cofactors of the elements of the matrix. Number 4 we get the adjoint of the matrix, and then finally we get the inverse of the matrix to be able to get the value of the unknown. So now we move on to lesson 6, which is sequence and series. So for the topics covered, these are functions with integer input, types of sequence, and types of series as well. Okay, for the objectives at the end of the lesson, the student should be able to, number 1, recognize a sequence as a function. So there's a difference between sequence and a series. And then for number 2, plot the graphs of a sequence, of the sequences. So if we are going to plot that one, it forms a line or it forms a curve depending on the degree of the equation. And then for number 3, we recognize specific types of sequences, which are the arithmetic, geometric, and the harmonic. Okay, and then for number 5, we convert the descriptive prescription of the output from arithmetic and geometric sequence. So we have added here also the harmonic sequences. And then for number 6, we generate the recursive prescription, or that is the function of a sequence from a given sequence of numbers. So the function is also called the sequence function. Okay, so that is um, number 8, manipulate series of powers of the natural numbers. So we now first define what is a sequence. So a sequence is an arrangement of numbers in a particular order of, or if we are going to reword that one, rephrase that one, that is just the ordered list of numbers or the terms. Okay, any function f whose input is restricted to positive or negative integer values n has an output in the form of a sequence of numbers. So arithmetic sequence is formed from the um, arithmetic series is formed from the arithmetic sequence. So we now have this example number 1, the function defined by the prescription if the function is f of n is equal to 5n minus 2, where n is a positive integer greater than or equal to 1. Okay, so for this one, we have the condition that the value of n there to be substituted to the function is a positive integer and it is greater than or equal to 1. So say for example we get the first 3 terms of the function. So let's say that is n is equal to, so it will be starting on 1, 2, 3, since 0 there is not included since the condition is n is greater than or equal to 1. So if we are going to substitute the values there to get the terms or the numbers or the lists, okay, and there is first we get that 1, and then that is equal to 5 multiplied by 1 minus 2, and that is equal to 3. Okay, so next we get the function. We substitute the value of 2 there, that is 5 multiplied by 2 minus 2 is equal to 8. And for the next, that is f of 3, that is equal to 5 multiplied by 3 minus 2, and that is equal to 13. Therefore, the terms are, the first 3 terms of the function is 3, 8, and 13. So that is and so on. Okay, for the first 3 terms, that should be 3, 8, and 13. For the function, f of n is equal to 5 and minus 2. So for example number 2, we move on. Okay, given the sequence, f of n is equal to 6 minus 3n, where n is a positive integer again, and that is greater than or equal to 1. So we start again the value of n to be 1, and then 2, and then 3. We exclude there the 0. Okay, so that is, we get here the first three terms. Okay, so for this example only, we get the first three terms of the sequence of the function f of n is equal to 6 minus 3 multiplied by n. So we substitute n there, which is 1, and then that is equal to 6 minus 3 multiplied by 1, so that is equal to 3. And then for the second term, it will become 6 minus 3, okay, that is multiplied by 2 already, is equal to 0, of course. And then f of 3 is equal to 6 minus 3 multiplied by 3 is equal to negative 3. So therefore, the first three terms of the sequence or the function is 3, 0, and negative 3, and so on. Okay, so for the graphs of sequences, since the output of a sequence consists of a sequence of discrete numbers, the terms of the sequence, the graph of a sequence will take the form of a collection of isolated points in the Cartesian plane. Since that is in a we plot the sequences to the Cartesian plane, we start the value of n to be equal to 0, since the origin or the starting point of the Cartesian plane is at 0, 0. Okay, so that is, the first term of a sequence need not necessarily correspond to n is equal to 1. It can correspond to any integer value depending upon the purpose to which the sequence is to be put. So for example, draw the graph of the given sequence. F of n is equal to n squared, n is equal to 0, 1, 2, 3. So we get the value, the four values for the terms. Okay, we substitute there to the function or the sequence, that is f of n, okay, is equal to n squared. So we substitute there a value of 0 to be equal to 0 squared, so that is equal to 0 from the origin, and then we substitute there the value of 1, which is 1 squared, that is equal to 1. Okay, next is we substitute there 2 for the third term, that is 2 raised to 2 is equal to 4, and then f for the fourth term, that is 3 squared is equal to 9. So the sequence will be 0, 4, 0, 1, 4, 9. So this will be the first four terms of the sequence. F of n is equal to n squared. So if we are going to check what is the degree of the sequence, so we first get the first difference. So that is 1 minus 0, that is of course 1, and then 4 minus 1, that is 3, and then 9 minus 4, that is 5. So if the difference of the first, okay, that is equal, that is first degree. Okay, but since the common difference are not equal, the degree of the function is not first degree, so that is a line already. And then if we are going to get the second difference, that is 3 minus 1, that is 2, and then 5 minus 3, that is already 2. They have a common difference, so 2 is equal to 2. The common difference is equal to 2, so that is a second degree function. So that is, if we are going to plot that in a Cartesian plane, that is already a curve. Okay, so if this will be the ordinate and this will be the abscissa, okay, the x ordinate will be the value of n, and then for the ordinate, we substitute there the value of the function, which is the sequence f of n. So that is 0, okay, from the origin, and then we just plot it there. We say that is 1, and then we just exaggerate, okay, that is 3, and then this is 1, this is 2, this is 3 for the y-axis, the ordinate, okay, 4, 5, 6, 7, 8, and 9. So for 0, of course, that is 0, and for the value of n, which is 1, the function is equal to 1 also, so we plot it there. So for 2, that is 4, so that is here, okay, and then for 3, that is 9, so that is a curve, so it forms a curve. So if we are going to connect the lines, it forms a curve. So that is in the second degree, which is a curve. Okay, it satisfied already our function or the sequence. So that is just the graphs of sequences. That is, we graph the terms, and then that is from the ordinate, that is the function, and then for the value of n, okay, that is the x or the abscissa. Okay, we have here next the types of sequences. We have here three types of sequences, which is the arithmetic, the geometric, and the harmonic sequence. So we have here arithmetic sequence first. So that is the general form, that is f of n is equal to a plus nd. So n there is equal to 0, 1, 2, 3, and 4. Okay, always we start from 0. And then for a, that is the first, okay, that is the first term, always. And then for n, that is the value of 0, 1, 2, 3, 4, 5, 6, and so on. Okay, so that is the terms, nth terms. And then for d, that is the common difference already. Okay, so if we have here an example, consider the sequence 2, 4, 6, 8, 10. So that is, we are going to get its general form. Okay, so if we have that one, that is 2, 4, 6, 8, 10, terms is obtained from previous term by adding 2 to it, since that is 2 plus 2, that is 4, and 4 plus 2, that is 6, 6 plus 2, that is 8, 8 plus 2, that is 10, and so on. Okay, the sequence is called arithmetic sequence for this one. So if we are going to rewrite the sequence, that is 2, 4, 6, 8, and 10. And if we are going to get the common difference for this one, since that is in the first degree, no, that is for 4 minus 2, that is 2, 6 minus 4, that is 2, 8 minus 6, that is 2, 10 minus 8, that is 2 also. So the common difference there is therefore equal to 2. So to be able to get the general form, we substitute the values to f of n is equal to a plus n d, where okay, the first term there is 2, of course, and then plus n, and then for the common difference, that is 2. Or if we are going to rewrite this, that is f of n is equal to 2 plus 2n. So this will be the function of the sequence. So that will be the answer, the general form. Okay, so example number 2, we have there, we consider the sequence of f of n is equal to 5 plus 4n, and then for the value of n, we start again from 0, 1, 2, and 3. So we get first the first four terms of the sequence. So if we have there 5 already, so that will be the first term. Okay, that is the first number of the list, in the list. And then 4 there is the common difference already, which is equal to d. So if we're going to get the terms, okay, that is f of 0, that is equal to 5 plus 4. We substitute the value of 0 to the function, which is equal to 5. So this will be the value of a, or the first term of the sequence. Okay, so next we get that one, the second, to be 5 plus 4 multiplied by 1, that is equal to 9. This will be the second term, okay, already, and this one is the first term. And then next we get there f of 2 is equal to 5 plus 4 multiplied by 2 is equal to 13, and that will become the third term. Okay, next is f of 3 is equal to 5 plus 4 multiplied by 3 is equal to 17. Therefore, that is the fourth term. Okay, so to get the sequence, okay, the first four terms will be 5, and then 9, and then 13, and then 17, and so on. Okay, for example number 3, we have here, find the sequence function. So that is the f of n is equal to a plus nd again, okay, of the given terms negative 3, 4, 11, and 18. So if we are going to rewrite this one to get the common difference, that is negative 3, 4, 11, and 18. So this will be the first four terms of the sequence, okay. So if we're going to check, okay, we get the common difference, which is 4 minus negative 3, so it will give us a value of 7. And then the same with this one, 11 minus 4, that is equal to 7 also. And then 18 minus 11, that is equal to 7 as well. So therefore, the common difference is equal to 7. So if we are going to write its general form, or the sequence function, okay, that is in the form of f of n is equal to a plus nd, so that will become f of n is equal to a, which is the first term, and that is negative 3 plus n, and then the common difference is 7. So if we're going to rewrite this one, that is f of n is equal to negative 3, and then that is the coefficient of n, which is 7. Then that is, so that will be our final answer for the general form. Now we move on to number 2, geometric sequence. So our previous will be the arithmetic sequence, and then second is the geometric sequence. So for the geometric sequence, we have there the general form f of n is equal to a r raised to n, where n there is equal to 0, 1, 2, 3, 4. So we start again from 0, okay. So that is the such a sequence is called a geometric sequence. And then r there is called the common ratio, because it is the ratio between any pair of these successive terms. That is the number that a term is multiplied by to find the next term in the sequence. So if we have your example number 1, consider the sequence 2, 4, 8, 16, and 32. So if we're gonna check, that is 2, 4, 8, 16, and 32. So if we're going to check if that is a arithmetic sequence, since that is AP, okay, we check the common difference. That is 4 minus 2, that is 2, and then 8 minus 4, that is 4, and then a 16 minus 8, that is equal to 8, and then 32 minus 16, that is 16. So that is not an AP. That is not a, sorry, that is should be arithmetic sequence. So that is not a arithmetic sequence, since the difference is not common. So to get that one, 2, 4, 8, 16, and 32, we get the common ratio, okay. So the common ratio will be 4 divided by 2, and that is equal to 2, and then 8 divided by 4, that is equal to 2 again, and then 16 divided by 8, that is 2 as well, and then 32 divided by 16, that is also equal to 2. Therefore that is a geometric sequence, okay, since they have the same ratio, which is equal to 2. So if we're going to get the function for this one, if we're gonna write, that is f of n, that is in the form of f of n is equal to a r n. So that is f of n is equal to a, which is the first term again, which is 2, and then for r, the common ratio, that is 2, and then that is raised to n. So this will be our final answer. That is the sequence function, or the general form of the geometric sequence. Okay, now we have their example number 2. Consider the sequence f of n is equal to 2 multiplied by 2 raised to 3. So sorry, that should be n, okay, sorry. So that is f of n is equal to 2 multiplied by 2 raised to n, where n there is equal to 0, 1, 2, and 3. So if I'm gonna rewrite that one, sorry, that is 2 multiplied by 2 raised to n. So for this one, of course, a there is automatically equal to 2, and for the common ratio, that is equal to 2 also. Okay, to be able to get the sequence, okay, that is, we substitute the values of 0, 1, 2, and 3 to the function. So that is equal to, okay, that is 2 multiplied by 2, okay, and then that is raised to n, which is 0, so that is equal to 2, and then that is, okay, 2 raised to 0, that is equal to 1, so that is equal to 2. And then for f of 1, that is 2 multiplied by 2 raised to 1, so that is 2 multiplied by 2 is equal to 4. And then f of 2, that is equal to 2 multiplied by 2 raised to n, which is 2 already, and that is 2 raised to 2, that is 4 multiplied by 2, that is 8. And then for f of 3, okay, that is equal to 2 multiplied by 2 raised to 3, and 2 times 2, 4 times 2, 8 times 2, that is equal to 16. Therefore, the sequence will be 2, 4, 8, and 16. So that will be the first four terms of example number 2. Okay, we move on to example number 3. We have there what is the general term of the sequence of terms for 12, 36, and 108. Okay, if we have that one, we just get the common ratio, which is, okay, if you're gonna rewrite that one, 36, 108. Okay, we get the common difference, okay, sorry, the ratio, common ratio, so that will become 12 divided by 4, and then 36 divided by 12, and then 108 divided by 36. So the ratio for this one is 3, same with this one, that is also equal to 3, and same with this, that is equal to 3 also. So if we are going to get the general term or the sequence function, that is equal to a r n, and that is, okay, that is the form. Okay, a there is equal to 4, since that is the first term, and for the common ratio, which is 3. Okay, so that will be the general form for example number 3. Now we move on to the last sequence, the harmonic sequence. So if we have there the general form, that is just the um, reciprocal of the AP. So, okay, harmonic sequence is just the reciprocal of the arithmetic sequence. Okay, so if we have that one, that is f of n is equal to 1 all over a plus nd. So for a there, that is just again the first term of the sequence, and then d there is the common difference. So first, a sequence of terms is said to be unharmonic in harmonic sequence if the reciprocals of its terms form an arithmetic sequence. Okay, so if we're going to check that one, example number 1, consider the sequence f of n is equal to 1 all over 5 plus 4n, n is equal to 0, 1, 2, 3. So we get first that one in terms of its arithmetic sequence. So the arithmetic sequence for this one is f of n is equal to 5 plus 4n. We get the reciprocal for that one. Okay, so getting that one, that is f of n, which is 0, so that is equal to 5 plus 4 multiplied by 0. This will be the first term. Okay, and then for f of 1, the second term, which is 5 plus 4 multiplied by 1, that is equal to 9. And then f of 2, again, that is equal to 5 plus 4 multiplied by 2 is equal to 13. And then f of 3, that is equal to 5 plus 4 multiplied by 3, and that is equal to 17. Therefore, the arithmetic sequence will be 5, 9, 13, and 17. So for the harmonic sequence, we just get the reciprocals of the terms of the arithmetic sequence, which is 1 all over 5, and then that is 1 all over 9, and then for the third term, that is 1 all over 13, and then for the fourth term, that is 1 over 17. So that is just the process of getting the harmonic sequence. Now we move on to our last example, number 2. Find the sequence function of the given terms, negative 1/3, 1/4, 1/11, 1/18. So if we are going to get that one, we get first that one in terms of the arithmetic sequence. So that is just negative 3, 4, 11, and 18, and so on. So if we're going to get the common difference, okay, that is 4 minus negative, sorry, negative 3, that is equal to 7, 11 minus 4, that is equal to 7, 18 minus 11, that is equal also to 7. So therefore the common difference for this one is equal to 7. No, so now we are going to rewrite this one in its general term or general form, or its sequence function, that is f of n in the form equal to a plus nd again, and then that is equal to f of n is equal to a, which is the first term, that is negative 3 plus n, and then the common difference is 7. Okay, so after this one we get now the general form, which is negative 3 plus 7n. So that will be in the arithmetic sequence function. So if we're going to get the harmonic sequence, we just get its reciprocal. So that is equal to 1 all over negative 3 plus 7n. So this will be our final answer. So that ends our topic on sequence. For the next video, we are going to talk about the series or the progression. Okay, so number series and the progression.